इस लेक्चर में हम लोग वेक्टर्स को डिटेल्स में पढ़ने वाले हैं। जितनी भी इंफॉर्मेशन आई विल बी शेयरिंग विद यू विल बी इम्पोर्टेंट। ओके, सो यस, ये लेक्चर हिंदी लैंग्वेज में होने वाली है। हम लोग स्टार्ट करेंगे इस लेक्चर को विथ द डेफिनेशन ऑफ वेक्टर एंड देन एट द एंड ऑफ दिस लेक्चर we will be on the advanced topics as well as on questions. So sometimes I will be using both languages, Hindi and English. Okay, so don't get confused. Now I want to start. देखो, वेक्टर इसको समझना कोई हार्ड नहीं है। ये डेफिनेशन है। अगर इसे एक डेफिनेशन के तौर पर देखा जाए तो ये कहता है कि मैं एक क्वांटिटी हूँ। वेक्टर सेज दैट आई एम ए क्वांटिटी। जैसा कि हम लोग जानते हैं कि दुनिया भर में इस वर्ल्ड में बहुत सारे क्वांटिटीज़ हैं एंड उस क्वांटिटीज़ को ऐसे तो बहुत सारे प्रेजेंट है क्वांटिटीज़। जब हम लोग फिज़िक्स के लैंग्वेज में आते हैं, जब ये वेक्टर आता है फिज़िक्स के लैंग्वेज में, तो ये कहा जाता है कि जो ये इतने सारे क्वांटिटीज़ है इसको दो पार्ट में डिवाइड किया जाता है। एक पार्ट में आ जाएगा अपना फिजिकल क्वांटिटी और दूसरा पार्ट में आ जाएगा नॉन फिजिकल क्वांटिटी। जब हम दोनों क्वांटिटीज लेंगे तो हमारा सारे क्वांटिटीज हमें मिल जाएंगे। लेकिन यहाँ मेन फोकस ये है कि सिर्फ हम लोग एक टाइप ऑफ एक पार्ट हम लोग लेके चलेंगे। हमारा फोकस सिर्फ एक पार्ट पर होगा, वो है फिजिकल क्वांटिटी। ओके, जब हमारा कदम फिजिकल क्वांटिटीज़ की ओर आगे हम लोग पढ़ते हैं तो पता चलता है कि ओके, वी हैव क्वांटिटी, बट this physical quantity we are going to divide into two parts again. Now these two parts, name of these two parts are nothing but a scalar quantity and vector quantity. Here, after understanding definition of a scalar quantity, we will ignore it. Then our full focus will be on discussion of a vector. Okay, are you understanding? First of all, we ignored physical quantity. Then now we are ignoring uh, a scalar quantity. मैं ये अज्यूम करके चलता हूँ कि आप लोगों को फिजिकल क्वांटिटी और नॉन फिजिकल क्वांटिटी के बारे में पता होगा। मैं डायरेक्ट पॉइंट पर आता हूँ। जैसा कि मैंने कहा कि स्केलर क्वांटिटी को हम लोग इग्नोर करेंगे, लेकिन हम लोग स्केलर क्वांटिटी को इग्नोर करें इससे पहले ये उचित होगा उसको समझना कि क्या डेफिनेशन है स्केलर क्वांटिटी की। सो when it comes to a scalar quantity is a physical quantity. It is not a physical quantity. Okay, when it comes to physical a scalar quantity यहाँ पर समझने की कोशिश करना यह है कि ये क्वांटिटी है। अगर हम लोग कोई भी चीज़ क्वांटिटी ले रहे हैं तो उसको तो मेजर कर सकते हैं। या स्केलर क्वांटिटी एंड वेक्टर क्वांटिटी, बोथ क्वांटिटीज कैन बी मेजर। मेन पॉइंट ये है कि जब हम लोग स्केलर क्वांटिटी ले रहे होंगे तो वो क्वांटिटी स्केलर क्वांटिटी विल नॉट बी एबल टू प्रोवाइड डायरेक्शन, वेयर एज वेक्टर क्वांटिटी प्रोवाइड्स डायरेक्शन। नाउ अगर हम लोग मैग्नीट्यूड के हिसाब से चले तो दोनों क्वांटिटी मैग्नीट्यूड विल प्रोवाइड, बोथ क्वांटिटी विल प्रोवाइड मैग्नीट्यूड। मेन पॉइंट इज डायरेक्शन. A scalar does not provide direction, vector provides a direction. This is a complete definition of both of them, I would say. Okay. So now we are crystal clear about a scalar is a quantity, physical quantity. It is a physical quantity, but it does not provide a direction. That's why this scalar is not vector. Okay. So both vector and scalar both provide but magnitude. Okay, you have understood. Now let's see how to the examples of vectors are we have force. Okay, force is an example of a vector. when force is applied on a box, then we see that in which direction force is being applied on the box. So direction is a compulsory to tell that yes, force is being applied on a box. That's why in for force we need a direction with magnitude. So distance is an example of a scalar quantity, because distance uh, it is considered as a scalar quantity because it provides only magnitude, not a direction. When it comes to displacement, then we are familiar with the displacement. Uh, it provides a magnitude as well as a direction. What are you understanding? यहाँ डिस्प्लेसमेंट की बात हो रही है और डिस्टेंस की। डिस्टेंस क्या है कि देखो, दोनों का अगर ध्यान से समझा जाए डिस्टेंस और डिस्प्लेसमेंट को, तो दोनों एक तरफ से देखा जाए, एक दृष्टिकोण से देखा जाए तो दोनों सेम टू सेम है। डेफिनेशन समटाइम्स लगेगा कि दोनों सेम टू सेम है, पर एक्चुअली में नहीं है। एक्चुअली में जब हम लोग उसको एनालाइज करते हैं तो पता चलता है कि नहीं, बोथ आर डिफरेंट। एक्चुअली में नहीं है। सो यहाँ पर हम लोग बात कर रहे थे कि डिस्टेंस एंड डिस्प्लेसमेंट बोथ आर नॉट सेम in the sense of, in the term of a definition. Not a definition, yeah, definition you can say. So यहाँ पर समझने वाली बात यह है कि distance is a scalar quantity and displacement is a vector quantity. When we say कि distance is a scalar quantity, it means we are saying कि scalar quantity is providing magnitude, not, it will not be able to provide a direction. That is what we are saying. Okay, that is what we are saying by saying distance is a scalar quantity. But when you are saying when we say that displacement is a vector quantity, it means we are saying displacement is providing what direction as well as magnitude. That's why we are able to say displacement is a vector quantity. Okay, any quantity, you are saying that this quantity is a vector quantity if that quantity is providing direction as well as magnitude, then you can say confidently with logic you can say that yes, this our this quantity is a vector quantity. Condition is that quantity should provide direction. That's it, to say that this quantity is a vector quantity. Now how to represent? With example we have understood meaning of a vector. Now let's see how to represent, how is it represented, this vector, how is it represented? It is a very simple. Symbol of a vector is very simple. If you understand once, this is represented by symbol. Now it's a time to analyze this symbol. Let's break down it so that we can get more clarity. Look at this segment. This is segment. This is segment. This segment is nothing but, in the language of a vector, this segment line is a magnitude, only magnitude. Okay, this is only magnitude. Okay. So this only segment line. I'm not saying ray line. Okay, this complete is a ray line, but one part of this ray line I took over here, which is it is a considered, this only this part of this ray line, it is a considered as a magnitude. When it comes to this arrow, only arrow without a segment line, this arrow is represented for direction. Okay, direction. This arrow is for direction and this segment is for magnitude. And combination of this arrow and this magnitude line segment will be known as vector, completely vector. Okay, combination of this arrow and segment is a completely what, vector. So this symbol is used as a vector, as vector. Okay, dramatically we can represent any vector. Okay, for example, length of magnitude is more, it is 10 centimeter, then length of the magnitude, length of this line segment should be 10 centimeter. It should not be less than 10 centimeter. it should not be greater than 10 centimeter. If you are representing any vector which whose magnitude is a 10 centimeter, in that, in the uh, in diagram, okay, I would say on graph, in that case you will have to show that yes, magnitude length of this magnitude is the 10 centimeter. Okay, if you are representing any kind of a vector whose magnitude is a 10 centimeter, then length of the segment of that vector should be 10 centimeter on the graph. Okay, on the graph. I hope you have understood about it. Now, next thing, एज अ सेड कि ये लेक्चर हिंदी और इंग्लिश दोनों में होने वाली है, लेकिन समटाइम्स मैं सिर्फ इंग्लिश में बोलते जा रहा हूँ, लेकिन कभी कभार होगा कि ड्यूरिंग दिस लेक्चर आई विल बी यूजिंग हिंदी लैंग्वेज, डोंट वरी. यस, नाउ आई एम अज्यूमिंग that yes, I am going to speak too much in English language. Don't panic about it. Okay, so to represent any vector, just draw this symbol. Now you can name like that any vector. So this complete is a vector A. It is a pronounced as a vector A, vector B, vector A, vector R. That's it. That's all. Okay, that's all. So this vector A, it is a combination of a magnitude. Look over here, magnitude, multiple direction. So this vector A is equal to, it is equal to magnitude multiple direction. We took magnitude this magnitude and direction this. Now in this case, it is said that A is a only magnitude and this arrow is a for direction. Yeah, it can happen. Sometimes it will happen. So don't get confused in this case. Okay, so this A will be nothing but magnitude of a vector. How to calculate magnitude of a vector, magnitude of any vector? Okay, to calculate, for example, right now we have this vector. This is completely vector. Now question is the same. Tell me what would be magnitude of this A vector. So simply you can say this is equal to A, because now this is completely A. So it is not equal to A. This vector is not equal to A because this is a magnitude and this is a completely. Now we can say this is a scalar and this is a vector. Okay. So to say here we will have to apply this mode. Now let me explain why did we use mode. It is used to remove direction of any vector. So here we applied this. Now it became only magnitude. Now this is equal to it. Okay. So remember, whenever we will be using a mode, it means we are removing direction, not a magnitude. Okay. Sometimes question will be asking. Sometimes it will be compulsory to remove direction in the question. We will see those kind of questions. That is how this direction is removed. There is a formula also. There is a formula also to find the magnitude of any vector. Till here I have to be crystal clear about it. Now let's see next part. इस तीन वैक्टर्स को देखो थोड़ा ध्यान से, यहाँ पर तीन वैक्टर्स आर गिवन. First, if a vector, if it is nothing but fourth, this f is a force. So here it is saying this vector if it is how much 10 Newton. But we, as we can see, this vector is given with a direction. That's why it will be complete vector. So this first vector which is equal to 10 Newton north. Now direction is a north. 10 Newton of force was applied on a box in which direction? In a north direction. That is what it is trying to give us information. Next vector is a saying. It is explained that 20 Newton, this much force was applied force on something, and in east direction. In which direction? In east direction. This is the completed data with the direction. Okay. Now next vector, it is saying 30 Newton force was applied on a box in this direction. This is not the exact direction. We have to analyze it. What is the exact direction? Now let's visualize this with the Cartesian plan. As you know, Cartesian plan gives us four direction. This north, this is south, and this east, this west, this west. First, look at first vector. First vector is saying 10 Newton, 10 Newton north, in a north direction. So north direction, where is the north direction? In this direction. How much force? 10 Newton. Okay, that is how we visualize 10 Newton force in north direction. Okay, second vector, 20 Newton force in east direction, in this direction, 20 Newton. This is the meaning of this given vector. Now third is a little bit different from the two vectors. So third is saying 30 Newton, 30 Newton. So now direction, it is not completely visible. This direction is not completely visible. So north 60 degree, rotation is how much? 60 degree. There was a force which was applied on a box in particular direction. So that particular direction is nothing but 30 degree north, north of east. This east and this south. So इस ईस्ट से नॉर्थ की ओर, ईस्ट से नॉर्थ की ओर. सो ये डायरेक्शन इस तरह की ओर जा रही है. कितना रोटेशन? हाउ मच रोटेशन? 60 डिग्री. 60 degree. This is our vector which is F3. F3, 30 Newton, and it is saying 16 degree north of east. From here, from east to north, from east to north. Okay. So this is our third vector. Third vector. This was about how to present any given vector on a Cartesian plan. As you have understood, this is how any vector can be visualized on a Cartesian plan. Now next thing which we have, angle between any two vector, any three vector. Okay, how to find angle between any two vector. Before we find angle between two vector, let's see what is the exact discussion of the angle between two vector with the Cartesian plan and with theory, with the theory. यहाँ पर आपको एक समझने की ज़रूरत ये है कि मैंने एक चीज़ डिस्कस नहीं की, वो in the part of in the discussion of represent how to represent vector. One thing that I left which is this the, so this ending part. There are two ending sides of this symbol. This one and another this. So this which is without this ending part, this ending side which is without arrow. This is considered as a this will be considered as tail. Okay, without arrow side which is without arrow is a tail. This left side which is with arrow, this is considered as a head. Okay, this is a head and this is a tail. This side is a tail and this side is a head. Now it will help you to understand these two things over here. Angle between vector. Look at, first of all we will have to see is a connection of vectors, is a connection of vectors correct or not. Okay, so how to say that the connection of vectors are correct? So look, connection of any given vector should be tail to tail, or it can be head to head. It should not be tail to head and head to tail. Okay, it can either it can be either connection of two vectors can be either tail to tail or head to head, then it will be valid for vector. As you can see, there is one example, angle between tail. Angle between tail, connection of these two vectors, as you can see, both are connected tail to tail. Yeah, we can see easily, both are connected tail to tail. Now it is a correct connection of these two vectors are correct. Okay, this is valid. So let's say rotation is at 30 degree and name of this vector is A and this is a B. This is B. You can see angle between A vector and B vector is a 60 degree. Okay. Now in this example, in this part, as you can see, both are not connected tail to tail, but still it is a correct connection. This connection of the two vectors are correct. Yeah, we can say in this part we were saying that the connection of these two vectors uh, were tail to tail. But in this part, as we are observing that both connection of this both vectors are head to head. In the starting, I said that it can happen if connection of both vectors are head to head, then it is valid for vector. Okay, this is not wrong. So this is the correct way. It will be invalid when connection of two vectors uh, are different. For example, tail to head, head to head. In that case, this vector connection of these vectors will be invalid. Let's say this is a 60 degree, and this is a vector, and this is a wave vector. Okay. So over here again, angle between C, D, C and D vector is a 60 degree. Okay, this is your complete answer. How much? 60 degree. Now in this part we understood how to find angle between two vectors. Okay, we are crystal clear about this part. Now one question I want to give you, which will be little bit different from this part. Let me give. this is our next next thing. Question is the same. Question is asking what is the angle between this given vector. What is angle? And angle is also given. Angle is also given. Let's say this is a 45 degree. Angle is given by the question. Now you have to answer. Somebody, I would say examiner gave you a question which is this. Examiner is asking what is the angle of these two given vectors. You would get confused. What examiner is asking angle between this given vector which is given. This angle amount of rotation is given, but still examiner is asking. Examiner is not full person. Okay, here you will have to analyze this question. Connection. What is the process? What is the process to calculate angle of any two vectors between any two vectors? Process is that first step is that we have to see is are connections of two vectors correct or not. If not, then we will shift. Yeah, shift word. Shift word. This is also a little topic, I would say. How to shift any vector parallelly. This is also a little bit topic, I would say. So let me explain how to shift any vector. Then I will complete this discussion. For example, there is a one vector. Which name is whose name is a vector. Now, can we shift this vector? Answer would be yes. We can shift, but there is a condition. We cannot exploit that condition. Condition is that you can change any given vector, but without changing its direction and magnitude. Okay, magnitude. So this length of this magnitude should be same. Length of this segment should be same. Direction, value of angle should be same. Now you can change. Parallelly, you can change parallelly. So this can be shifted over here. We didn't change length of this magnitude, and we also didn't change direction of this vector. That's why this is a correct way to shift any given vector parallelly. We shifted this parallelly. It can go upward, it can go downward, it can go this side, it can go this side. But there are two important points that we will have to keep remembering in our mind. Is first, we don't need to change its direction as well as its magnitude, but still we can shift this vector anywhere on a plane. Okay, on a plane. Same this logic we will apply in this discussion. Here, connection of these two vectors are not correct. Now our work is to shift any of these two vectors parallelly. If you want to shift this vector, you can shift. If there is a person who wanted to shift this vector. Yes, this is also valid. Let's shift. I am going to shift this vector. Okay. So this will go over here, and this will be as it. So this was C vector, this is a D vector. Now connections are correct. Would you say Okay, connection are correct. Angle is 45 degree. Now this is our complete answer. But I still you are you are wrong. You are wrong. This given angle is a amount of this rotation, amount of this part. But angle we have this part. We have to tell what is the angle of this rotation part, not this part. As we know, it is making a linear pair angle. You are familiar. It is making a linear pair angle which is equal to 180 degree. If this we got two angles, this one and this another. So sum of these two angles would be equal to 180 degree. If this first angle is 45, we will subtract this 45 by 180. We will get another value of another angle, which is 135. Okay, this part is 135. This is our complete answer. This is the process. First of all, we shifted this vector over here, then it became it became correct connection. Then we found angle. So angle came out as a 135. This is our answer. And examiner was not wrong. We were also not wrong. We had to analyze. Now next thing. Now next. Question is the same. Question is the same. We have to tell what is the angle of between this two vectors, between A vector and B vector. As we can see, connections are not correct. So that's why any of these vectors you can shift any. So this is one. This can go downward, and now this was a 60 degree. As you know, this straight line is a linear pair angle. So if this angle is a 60 degree, so this part will become 120 degree. So this 120 degree. It was our factor and this was our factor. Now angle between these vectors is 120. This is our final answer. Next. Question is asking angle between angle between A and B and C and A from this figure. Figure is given. It is a triangle whose each interior angles are 60 degree. This 60 degree, this is 60 and this is 70. As we can see, let's start from this two vectors A and B vector. It is like this. We can see both are connected head to tail, which is incorrect in the language of vector. That's why we will have to shift this and you can shift uh, any of these vectors. I am shifting this over here. So now if I shift this over here, so this was 60, now this will be 120. So it's not our 60. Our angle between this A vector and B vector would be 120. Now next angle B and C. So where B and C both are connected head to head, that's why this is the correct connection of this is the correct, which is 60 degrees. So this would be 60 degrees. Now next A and C, or you can say C and A, both are connected tail to tail, whose angle is a 60 degree. So this would be 60 degree. That is how you will find the angle between any two vectors. Any two vector. Now next part. Next part. We have took we have taken next step. In this part we will see what we will see types of vectors. We have completed we have completed previous part in which we were discussing about vector, about how to represent any vector, how to find angle between any two vectors. Now our work is to discuss about the types of vector. There are written some, I would say it's all these are uh, we have not only we don't have only this vector. Apart from this types of vector, there are more. But I would say for this for your standard, this will be enough. This types of 10 types of vectors will be enough for your standard. Look at this. Types of vectors. uh, it's not difficult to understand all these types of vector. Once you understand it, it will become very easy for you. It is my guarantee. Just to, with a full focus and try to understand all these types of factors. Whatever I will be saying about these types of factor, you will have to understand all those importance that I will be sharing with the carefully. Okay, just I want your attention, attention, because it takes attention and time. Okay, now I am going to start to share a definition of equal factor. As you know, all these are types of factors. Uh, we are taking this first equal factor. So when you are saying equal factor, it means it is already a factor. You are saying equal factor, it means it is already, this is already factor. Now, what is the exact definition of equal factor? From the word, from the word which is equal factor, we can understand it without any other person who is explaining about it. If you are not able to understand with this given word, don't worry. Equal means this equal means equal. Both sides are equal. There are two sides. This side, for example, magnitude of this side, this quantity is 5 centimeters. So in this side, magnitude of quantity will be same 5 centimeters. This is the meaning of equal. This was just an example to understand about equal. Now here vectors. There are two vectors. Okay? There are two vectors. Magnitude vectors whose magnitude and direction both are same. Both are same. For example, this one vector. Magnitude of this, let's just say 2 centimeter, and direction in this direction. Now another magnitude of this vector is the same, which is 2 centimeter, and in which direction? In this direction. Let's just say there is a one box. There is a one box. This much forces, I would say Newton, 2 Newton, 2 Newton, 2 Newton. Okay. 4 Newton, this much force are being applied on this box. So these two vectors are nothing but equal vectors, whose magnitude and direction both are same. This was a definition about the equal vector. Okay. Now next, parallel vector. Parallel vector. In this case, in the discussion of a parallel vector, here magnitude can be increased. Magnitude will be anything. It can be anything. Magnitude of a vector. This magnitude of a vector is, let's say, 6 Newton, and in this direction. In this direction. Now here, from the word is a parallel. So parallel of this can be like this. It can go over here. It can go over here. Another one. This way, B vector. This was A vector. So it can go anywhere. But condition is theta should be 0 degree. If you shift this over this vector, then theta will become 0. So this triangle should be 0. Okay, this was condition. Magnitude, I would say magnitude would be anything. It can be anything. Direction should be same. Direction should be same. If a direction will be different, then of course theta will not come as 0. Okay, 0. So direction should be same. Magnitude can be anything. I hope you have understood parallel. Now next. Now in some sentences I can explain parallel vector. There those vectors was theta, was the angle is 0 degree. Okay, magnitude can be anything. Direction should be same. In that case, we will get a 0 angle. Now next we have anti-parallel. Next we have anti-parallel. Anti means opposition. Opposition. Anti-opposite. This is vector. So opposite of this vector would be nothing but like that. This is our opposite. So another vector is another vector is B. Look at this. Here our theta would be nothing but 180 degree. Our theta would be 180 degree. When you will shift this over this vector, then our theta will become, as you can see, this, it will come over here. So our theta will be 180 degree. Okay, our theta will be 180 degree. I hope you have understood. So theta should be 180 degree, and same point. What? Length can be anything, but direction should be opposite. And angle should be 180 degree. Okay. This was about anti-parallel. Now next we have negative of a vector. You have a vector. Now question is asking what would be negative of this given a vector. Just you have to answer like this. This is a vector, given vector. Now negative of this would be nothing but direction of this vector will be opposite. So it will go like that. Length would be same. Length of the magnitude, length of the segment would be same. Direction will be opposite. That's it. So remember, in the discussion of a negative vector, magnitude should be same. Just direction will become positive, opposite. Okay. This is how we do any given vector like that. Now next, coplanar. Yeah, it is also easy to understand coplanar. There can be a lot of vectors. Collection of vectors. We are understanding coplanar vector. Collection of a vector, or you can say group of vector. Group of vectors are on a plane. For example, this one vector, this one, 1, 2, 3, 4, 5, 6. There are 6 vectors, and all these 6 vectors are on this plane surface idols. So collection, those vectors that are on a plane surface, those will be known as a coplanar vector. Okay. So next we have coinitial. Coinitial vector says that any vector should start from point. This is a point. Any vector should start from point, and I would say tail should be connected to that point. So this tail. So we are starting a vector. So it should go. Length can be anything. In this case, our focus is any vector should start from a initial point. This initial point, like that. It can go like that. Number of vectors can be anything. It doesn't matter. Matters is that vector should start from initial point. Now next we have orthogonal vector. Orthogonal, which means angle is 90 degree. Angle between two vectors. This one and another this. As you can see, both vectors are making 90 degree angle. So this 90 degree angle, two vectors who are making a 90 degree angle, this type of a vector is known as orthogonal vector. Okay. This A vector and this B vector. Collinear. This is linear. Linear means there can be more vector, collection of vector. So this one vector is like that. So another vector is along this vector. It is not upward, it is not a downward. This can go, this will be ahead or backward. This can be nextward or backward. So definition for collinear vector would be any vector who are along a line, along a line. Right? This part is this part is written. Let me write next thing which is important for you. Look at over. This is vector, a vector. Now question is saying what would be double of this vector? Two times of this vector. You would say like this. Just you need to increase this magnitude, which should be double of this. Double like that. Let's say this is a double. So now this will become 2a vector. So it is just a double of this given vector. Three times just increase. Three times just increase this three times of this. Then write 3a vector. Three times of a vector. Okay, that is how you will multiply. Now let's move on laws, vector addition. Vector addition law. Polygon law. Polygon law. Dramatically, we understand it like this. There is a one vector, this one. In polygon law, there can be number of vectors can be any number. It is not valid. In triangle law, number of vectors will be limited. It would be three. To create a triangle, we should have three line segments. That's why we will have three vectors. To create a polygon law, numbers of vectors can be any. Okay, can be any. Parallelogram. For parallelogram, we will have limited again. Number of vectors should be four. Would be four. Okay. That's why we take polygon law. If you have more than four vectors, then you can use polygon law. If you have three vectors, then you can use polygon triangle. If you have four vectors, then you can use parallelogram. Okay. Now look at this. This is one vector A, another vector B, another vector C, another vector D. All these vectors are connected to each other. We can easily see. This vector A is connected to B, B is connected to C, C is connected to D. All these are connected. So what is a polygon law? Dramatically. What is? Polygon law, polygon law says, polygon law says, just connect this, just connect another vector which should start from initial vector and it should end till the end vector like that. Okay, like that. I hope you have understood. You have understood. So next after D will come E. This is our resultant. It is known as resultant vector. resultant vector. This was about polygon law dramatically. Dramatic. Just connect, just draw a third resulting vector which should start from initial vector and it should end till the end vector. Till the end vector. That is how. So our resulting vector is what? For this vector are A plus B plus C plus D. This was a dramatically, but when it comes to mathematically, this is a little bit different. Now next, it is going like this. Like this is another question. You have to solve this uh, by polygon. What would you like to do? What would you like to do? You want to do this vector A. This is vector A, vector B, vector C, vector D, vector E, vector F, vector Z, vector H. Next would be our resulting one. What would be resulting vector? By using polygon. As we can see, there are more than 4 vectors. That's why we are able to use polygon. It says that just you start from initial vector. This is initial vector. So initial side, take initial side. First select initial vector and then select initial side. This is known as initial side. So draw a resulting vector. You should start from initial side of the initial vector. So this is initial side. I would say tail. Okay. Now where to end? Question is where to end. So end. Select last vector. I would say final vector and final end. Final end. So this is a final vector, final end. So it will end over here. This will end over here. So this will be known as resulting vector. This will be known as resulting vector. Okay. Vector A plus vector B plus vector C plus vector D plus vector E plus vector F plus vector Z plus vector H. This was about the polygon law. Now next, there is a twist in the next. There is a twist. I am saying this is our yeah. We have another issue. This Kishan is asking. Kishan is asking again, what is your resulting vector in this figure by using polygon law? Are you getting confused? Answer would be, we don't have a space. You would say, yeah, this how resulting vector will come in this figure. All these are connected. All these are closely connected. This is a curved line. All these are connected. There is a no space. That's why here, for in this case, with magnitude of resulting vector. So magnitude is zero. Magnitude is zero. If magnitude is zero, so we can say there is no direction. Have you heard this null vector or zero vector? Whose null vector is a vector whose magnitude is zero. So magnitude is zero. You can say resulting vector is a null vector. Okay, like that. Direction would be like that. Magnitude is zero, or you can say this vector zero. Vector zero.